and after that we'll do some review for the final and some review for the oil burner. So Thursday, Tuesday, and next Thursday we will just do a lot of reviews and go back again to the trivia questions. And I have another 50 questions that we still did not go through, and they are the most recent ones. And hopefully everybody will pass the exam. The sad thing is, from last year, people did not take it very seriously, and some people missed it by 1 or 2 questions. So take it very seriously and solve the question.
Are there like retakes or anything for it?
Yeah, you have to pay again.
Oh,
Yeah, that's a lot of money. And just FYI, if you get the license and you pass, don't let it expire.
No, I'm not using it.
Yeah. So every year you have to pay every 2 years you have to pay $75.
For 2 years?
Yeah. Yeah, well, at least you don't have to pay the exam, yeah. And if you are in a job that requires to have a license, have the job pay for it. Yeah.
Like, do we get like a thing in the mail saying what our date is or anything?
Yeah.
Yeah.
You should. And once you do, please let me know. We can get together, spend a few hours, and do some kind of review. So week 13, we're still industrial boilers, and this one is the Fire Eye M and E series. This is the Fire Eye. M series, it's very common. Probably you'll see it in some big boilers. If you look at the HP split we have here in the shop, they all run the Fire Eye M series. It's very simple, but very accurate and reliable. So we'll get familiar with them. I put the manuals on Blackboard, and probably if you go on Google and just do Fire Eye M series PDF, you'll find the manual. We'll talk about the wiring, control, some of the specificity of the boiler, of the control. What are the alternatives? How do we change or alternate the timing or the flame sensor? Electrical nomenclature for Cleaver Brook, I put that in Blackboard, so I'm not going to go over it. And again, the nomenclature are always for specific to the industry, so they're not always universal. Last quiz is done, it's from last year. Forget about that. So, from our relays, we took that last semester. Alarm relay, single pull, double throw, that is Sp19. You'll see this acronym in a lot of it's abbreviation on a lot of those controls. It will say Sp19 alarm, and people use that abbreviation a lot without knowing what it means. It's actually single pole, double throw relay. It's an electromagnetic switch, the system of coil, on the terminal 85 and 86. And basically it can be used to either turn on a light or make a sound. So it's double throw, it will cut off the circuit from the control, and at the same time sound an alarm. So it's double throw. That's why it's single pull. Single pull basically has one input and 2 throws. This is what it looks like. You'll see a lot of these relays from the inside, and this is the Fire Eye series from the inside. If you look at it, we have our alarm, and also we have a relay here that does the timer function. This is the Fire Eye M series, and if you see here, it has a sequence of operation. We will try to wire this next week, or at least either this or the Honeywell. They're very common. It has a sequence of operation, pilot flame activation, airflow for pre-purging, then main flame, and the end. If something goes wrong, there is an alarm and one reset button. Everything is closed inside, and from what we saw yesterday in the lab, that if you take out they don't want to do a lot of wiring and unwiring, because what happens when we keep wiring and unwiring? We had that issue with the primary control. The wire gets stretched, sometimes they don't connect very well. So they want to be connected properly and not be tampered with a lot. So if you have to change the controller, you can take it off completely and put it back in again. And these controllers are really expensive. So they're really well made, and they put a lot of effort and reliability studies on the relays and the condition inside. This has to be approved by a lot of laboratories. The main one is Underwriter Laboratories. So if we're thinking to go through insurance, it has to, guys,
It's for industrial.
huh?
Industrial.
This is industrial
Yeah.
and commercial. So if you notice, everything that's commercial, industrial has to go through a lot of testing to make sure it's safe. Because again, for industrial boilers, there is a lot of flame and there's a lot of probability of failure. So you want to make sure that these things are very, very reliable. And as Romani said, a lot of the issues with boilers is low water. So low water is a big issue. So you want a control that will respond quickly to low water and cut off the system. Guys, can you please keep it down? So what does this control do? It's very compact. It does some kind of modulation for low fire and high fire. If you see the control here, you can have two modes of fire, either high fire or low fire. And based on that, it will modulate the air coming into the system. Some of them can be used with either oil or with gas, so you can alternate the fuel with the same controller. They give you automatic ignition, continuous flame monitoring throughout the cycle, and for commercial site heating process, to make steam or to make hot water. And again, it can use gas and oil. And what is the purpose of using either gas or oil? It's two things we said: availability and cost. If we don't have oil, we can use gas. We cannot cut off the heat from big buildings. And again, sometimes gas is cheaper than oil, so you might want to go with gas. What are the disadvantages of gas? Sometimes it's low energy density. Fuel give you a lot of BTUs compared to gas. So overall, for BTUs, you could be better off with gas, and then you can be better off with oil. Flame monitoring system is accomplished by miniature UV sensor and or a flame rod. Can we use more than one flame sensor in industrial boilers?
Probably use that one.
Huh?
Yeah.
Good, right?
You could. So many times you use only one, but you could use two. If you use two, would you put them in series or parallel?
Series.
Parallel.
Who says parallel? Raise your hand. You are correct, parallel, because you want redundancy, or otherwise what's the point? One doesn't work, the other one is not going to work. So you put them in parallel because it's for
So
redundancy.
if you have more than one, choose for like pressure protection.
No, for like, it's the redundancy. So if one of them doesn't give you the signal, the other one will, and you'll get better performance. Specification, flame monitoring is accomplished by a miniature UV scanner. It's very small, or a flame rod. So what are UV and flame rod called? It does a process that changes AC to DC. What is this process called? Rectification system. So they are put in a rectification amplifiers, and that's what changes the signal. So if you look here, this is the amplifier, and in most of these controls, you can change the rectification system to have something that will react with the right sensor. So they give you the flexibility of changing timing and changing the flame sensors. And if you think about it, they're trying to make those controls more universal. They want to be universal, so they will cover up wide range of chamber size. So you want to be able to change the amplifier, and you want to be able to change the timing. They have an interchangeable programmer and amplifier modules allowed for complete versatility in selection of control function, timing, and flame scanning needs. How do we change those? You can either, there are two things, let me write them down. Some of these controls, you need to change. Change the amplifier, or cut off jumpers, yeah.
What's that noise?
It's actually the steam pipes because the
You
sharp
said it's
water.
It's hammering.
Yeah, so there's something wrong with the condensate. If you have this kind of noise, it's trickling water going down. What?
It was wilding yesterday.
Yeah, yeah.
Really bad yesterday.
What happened, they shut off the condensate pump, so we have too much water. Good example.
And they turn off the
They turn off the heat, but there was still some steam coming because it's still cold, so it's not returning very well. So there are functions. Let me show you some of those ways to change the amplifier. Like for this one, this is a 5i M series. You change the cartridge. This looks like the Atari thing. And this here is a miniature UV sensor amplifier module, and it also says 4 seconds maximum reaction time. And they give you the models where this is compatible with. And if this doesn't work, you just blow on it and put it back on the skin. Remember those things?
Could work on my forehead. just to
Yeah.
make sure.
I don't know what it'll work, to be honest.
Yeah, they say not to do that.
Yeah, but it does work. It does work.
Wait, I'm sweating the cartridge.
Oh, we still
Good compressed
we let
air.
them the tire and we all wait for the, if it's really old, we all wait for it to work and we all blow on and wait for it to come inside. Sometimes you get squares, it doesn't work, and you put it again, and it was very terrible. But these things are very old. Now you can go into like LCD screen. It has a program in it that you can upload or download a USB flash drive. So that's way much. So type of flame scanners either can have UV or flame rod. In the event of ignition failure, the following safety shutdown will take place. It will lock out completely, probably will reset, and it will give you, depending on how many times it reprogram, how many resets you can get, then you have an alarm and some technician has to go there and check those wiring. There's also a function of remote reset, where you can reset this from the control room. Again, if we are in a power plant, or any small power plant, even the one we have here in building 17, you will find out that you can touch, you can see all the functions from a control room, because it's easier for you to reset from the control room, or see what are the errors you get, instead of going all the way to the boiler and coming back. So they have, this one has the function having a remote reset. Can you do that with residential boiler? No, you have to be there at the boiler. I think it's also against the code to be able to reset the control from far away. So there are some control that incorporate safety checking circuit for each start. So before it starts and before it does the pre-purging, it will check all the components, and sometimes it will not even attempt to start if one of the components is not responding. What are the components? We have, for example, the airflow switch is not working, the oil valve is not responding, or the pressure gauges are not at the right setting. So it will not energize it, will go to lockout right away. That means something from the system check is not functioning well. Temperature operation is very similar to what we had before. Again, we said minus 40 Celsius or minus 40 degrees Fahrenheit, and maximum 125, which equal to 52 degrees Celsius. So this is the most general amount of temperature that all those control work with. And why would the temperature change? Something in the control. Why is it very temperature sensitive? Well, I mean, between that 75 degrees, 73 degrees, that's not a bad range, but still, it's a little bit sensitive. If you look at the control, it has a printed circuit and very, very small wires and timers. And as Emmanuel talked about the timers, some timers are built as an integrated circuit, which are small components. Those small components do change resistance based on the heat. So if it's too hot, probably it's not going to give you the right timing, and that will mess up the circuit inside the board. This is the programmer that you just took out in and out. That's basically what you can go and change based on the boiler size. And probably you can also go to the manufacturer and request a change based on the code.
So what is it actually amplifying?
It's called an amplifier, or basically it's signal coming from the flame rod.
Okay.
So you can read it in the control. So you'll get a small micro millivolt and one that amplifier to be able to close or open a circuit. These are the types of UV scanners you can use with. This is a small UV scanner. There's an ion here to absorb the light. This is also another kind of UV scanner. And this is a flame rod. Flame rods usually between 6 inches all the way to 30 inches. And if you look at the gas burners we looked at last week, we had like 3 inches, 2 inches flame rods. And they react with the ion. Another flame sensor that's UV, and sometimes you might need to have more than one to make sure that you have the flame. The reason again we use UV and flame rod is because we want to know what is the amount of flame we are producing, not because just we want to know if there's flame or no flame. Is it direct flame? Is it completely combustion or not? So you want to know the quantity of the flame, and this is the two ways that we can measure the quantity of flame. For the location, it should be within 30 inches of flame to be monitored. It's one of the questions of the quiz. If it's too far, probably it's not going to be able to detect the flame. So 30 inches is around like 2.5 feet. So it's not that far. But if it's further than that, probably it will affect the visibility of the sensor. Can you see that, Carlos? Yeah.
Absolutely not.
So it's 30 inches from the flame.
Wait, why do you have it that small?
Well, it seems visible.
Let's see.
I can see it.
Come back here. Yeah.
I can see it.
Oh, yeah, well, yeah. You know it, check your bedroom.
You got 40.
It's hard, but you have to focus. So this kind of location that remains within ambient temperature. So that means that UV does not want to be too hot. So it's going to be far just to visually see the flame, but not too far and not under a lot of heat. Mount rigidly a short length black iron pipe in a position that permits the unobstructed view of the pilot and the main flame. In summary, put it in a place that is not movable in a specific mount to be able to completely visualize the flame. Scanner must not sight the ignition spark directly or any part of the burner that can reflect the spark back into the scanner. So something with the spark that will disrupt your UV. The spark is different color. The spark is electrical. So you don't want to see the spark, you want to see the flame.
Sounds like a mirror back.
Yeah, and the spark is what color usually? It's bluish, so probably it will offset the sensitivity of the UV scanner. Maximum UV signal from the flame is found in the first third visible flame taken from the point where the flame begins. That's very interesting. Where do you point it inside the flame? So look at that. 1/3 of the visible flame taken from the point where the flame begins. That's very good. I'll do it over there. Out of words. None. Okay, I'll go ahead. So this is the flame. I want you to look at the flame. This is 1/3, 2/3, 1/3, so 1/3. I want you to point your UV detector to the first third of the flame where the flame begins, not this third, this third. Because you know, as the color changes, as the intensity of the flame changes, you have different UV. And where's the hottest part of the flame?
Tip.
Not the tip.
The-
It's before the tip. It depends on the color and the flame. So if you did any kind of welding or soldering, they tell you don't use the tip, use a little bit below the tip, depending on the gas you use. If you use acetylene, or mouth gas, it depends on the color of the flame. So each color have different temperature. So that's why you want to know which side of the flame you have to view before you can size up your flame. A correct scanner application will not see pilot flame that is too small to ignite the main flame reliably. So if the flame is on it, again, they are very, very sensitive flame detectors, and they're very accurate. So if the flame for the pilot is not strong enough to ignite the main flame, it will shut off. So you have one scanner on the pilot and one scanner on the main flame. Unusual for the main flame, probably you have a flame rod. But again, I light the main pilot, even if there is fire, does not mean it's the right fire, it's the right amount of temperature. So if it's not enough, probably it will shut off. Two scanners may be installed in one burner if necessary to view two areas to obtain reliable detection of the flame. And they should be wired in parallel. We talked about that. So let's say you have a big flame and you want to know what is the actual size of the flame, and you want redundancy, probably you want to have two scanners. The UV eye scanner is designed to seal off the side pipe to a pressure of 1 psi when the scanner lock not firmly tightened. Pressure of the excess of 1 psi should be blocked from the scanner. What does that mean? So the scanner is UV. So what does it have in the front? Glass. Has a glass side glass. This glass is not rated to be more than 1 psi pressure inside the boiler. There is no pressure. There should be no pressure. So if you have for some reason excess pressure, probably you have to provide some kind of protection. So you block the excess pressure from the UV scanner. You can use a quartz lens coupling to either magnify the flame so it will see better.
So that's how you increase this sensitivity?
Yeah, you can increase the put a quartz lens on it, make sure it sees bigger, and also it also can protect against the pressure. You can go up to 100 psi inside if necessary. So there are some things you can do about that. To increase the scan sensitivity, you can put a magnifying glass. You can put quartz lens to permit location of UVI twice distance known as item 1, which we say like 30 inches. So if you have to be further, you can put a magnifying glass so it can see the light correctly. This is again from the manual. They tell you as close as possible, 30 inches or closer. As cool as possible, never exceed 200 degrees inside the chamber. Avoid sighting the spark. You don't want to see the spark. You should see the pilot and or the main flame. And if you look at the construction, you want to see a complete view of the flame, not half of it, because you want to absorb the most amount of UV possible. Flame must be completely covered in the side glass. Again, you want to be complete inside the side glass, not portion of it. These are some of the scanners and their magnification, and this is where you can see the flame rod here coming inside. So some of them are small, they come in a flame rod assembly, and some of them are just visuals with the quartz lens. Okay. LEDs on the controller. So there are 5 LEDs. They just tell you the operating control. What do you need to know? I want to know if there's an alarm. I want to know if the pilot is ignited, the main flame is ignited, and if there's a pre-purging. Again, you will only have 5 LEDs here, and there's no error or side glass. In some other controller here, there is a small screen that will communicate with you and tell you what's happening and what kind of error you have. And those came actually in the 90s and early 2000s. And probably now for new boilers, you'll have complete LED screen. That'll tell you alarm. You can scroll and go to the history. Airflow. So this is very important. I will check your airflow and damper motor. Make sure there is airflow before you start anything. If there is no airflow or air pressure switch activated, the system will go into alarm. PTE5. That will tell you that the pilot trial for ignition period. So PTE5 is like we're trying to light the pilot. If we did not light the pilot, we're not going to continue but we'll go back again and do a pre-purge. Flame on, that means the main flame is on, and the system is energized and it's a manual, it's an autopilot, it's completely running. And finally, the alarm. If any of these four goes wrong, the alarm will sound and it's not going to function. So for the wiring, if you block all the connections in here and just focus on the numbers, it looks a lot like the primary control from Honeywell. So the UV scanner will go into S1 and S2, any sort of FF terminal. If you go to the pilot gas, 5 main fuel, 4 is spark ignition, and terminal 1 comes from the hot line, and all of these will have neutrals. And here we have our limit switches and the controls. A will go to the alarm lockout, and this goes to the burner motor or contactor. So we have a huge contactor because we will have a big motor. So the contactor will engage using the burner motor. So these people take some time trying to wire this into the boards, and it's really fun to see it work and see all the sequence of operation, especially in those big boards. This is also the sequence of operation. It helps you know what's going on. So it's good to go with the manual sometimes and observe what's happening with the system. So the first, this is again a timeline. Safe start. It turn on, nothing will happen. It's doing self check. So don't be alarmed and think it's broken. Just give it some time, and that should be around like 10 to 15 seconds. Then you have 10 seconds for the pilot to activate, and running period. So the pilot can get up to 10 seconds. What about the main flame? Less than 3 seconds. 1 second, a portion of a second to operate. If it doesn't operate right away, this will go out. So pre-ignited, CPA5 with flame after terminal 5 is energized. Recycle on loss of airflow after flame proven. And again, it will start over if it doesn't work. For troubleshooting, of course, there's a lot of possibilities of troubleshooting, but I'm not gonna go through it. But I put the manual on Blackboard, so you can go look at it from page 24 and 25. They will tell you. They have a big diagram. If this happened, follow this. If this happened, follow the other thing. The manuals are available online. I found a good version with a good print, so try to check that out. The Fire E-Series is very similar. Same sequence of operation, just different configuration. So you gotta, if you want the manual, it's also on Blackboard. All right, I think that's enough about industrial boilers. And if you were to work with industrial boilers, at least you know the sequence of operation. You know how sensitive they are. You know you can change things, and you know they are programmable. Okay, I will start the
That's
lecture.
pretty much what homework 6